Hello everyone. Today we're doing a continuation of last week's video where we looked at concavity, and today I'm going to show you just how easy it is to find those inflection points that we were talking about and those intervals where the function is either concave up or concave down, because I have constructed this perfect little function, right? So we have our f of x is going to be equal to 3x cubed, let me write the equal sign, 3x cubed minus 3x. So we're going to find the intervals where this is concave up and concave down, but first we're going to find the inflection point. Now how do we do that? Well, it's just as simple as finding the second derivative, so we're going to take the derivative twice, and we're going to set that equal to 0 and solve for x, right? So let's take our first derivative, right? When we do that, we're going to get, let's see, the derivative of this is going to be 9x squared minus 3. And now we're going to take our second derivative, so we're taking the derivative again, and that is going to be 18x. All right, we have our second derivative, so let's set that equal to 0. 18x equals 0, and let's solve for x. So we're going to divide 18 on both sides of the equation, and we'll get x is equal to 0. All right, so that's our inflection point. All right, I'm going to write that down. We'll say IP, right, inflection point, is equal to 0. That's where it's located. So now if we draw a little number line, kind of like how we were doing when we were finding the intervals where we're increasing and decreasing, let's draw a number line. Let's do it right down here, right? So this is what it'll look like. Not a perfect line, but it's all right. And right here in the center, right, this is 0. And again, we'll say this is where our inflection point is. We only have one. So that means all we have to do is test one number on the left side of the inflection point and one number on the right side of the inflection point, and we will find the entire interval where this function is either concave up or concave down, right? So what's an easy number to the left of 0? We'll say -1. That's super easy to test, right? And so we're going to plug -1 into our second derivative, right? So our second derivative was 18x, right? So if we plug in -1, we'll say f double prime of -1. 18 times -1 is just going to be -18. Okay, and now let's test an easy number to the right of our inflection point. We'll say +1, right? And so if we find the second derivative at 1, so f double prime of 1, that's going to be 18 times 1, so that's just 18, right? And if you plug in any number to the right of 0, you're going to get a positive number. If you plug in any number to the left of 0 on the number line, you're going to get a negative number, right? So what does this mean? It means if we have a negative number on that interval, it is concave down, right? So from the left of 0, but not including 0, from right here on forever, right? On forever, we're going to be concave down. This is not official notation. I'm just writing this because it's easy. CC and then a down arrow. So concave down, right? And then to the right of 0, like we just said, we're always going to get a positive number when we plug that into our second derivative, right? 18x. So from the 0, but not including it, all the way to infinity, it's going to be concave up, right? And that's it. We just found our concavity of the function, right? What we do is we take our second derivative, set it equal to 0, find where our inflection point is, and test the points to the left and right of each inflection point to find the intervals on which our function is concave up and concave down. So I'll write this out one last time. Our interval is concave down from -infinity to 0. And we're using parentheses because 0 is not included, and you just always use parentheses with infinities. And it is concave up from 0, parentheses because it's not included, to infinity. And then our inflection point is right at x equals 0. If you made it to the end of this video, thank you for watching. I really appreciate it, and I hope you learned something.